Let me take the pleasure to introduce Mr. Dino Joseph to you. He is the director of Mergior Private Limited, a company working with the NIT TBI. And I would say a very practical oriented person with a lot of good ideas and having a wonderful company with a good healthcare product in his profile. So, and he has already received the fundings from many good schemes of Government of India. I think better Dinoj will definitely give a little bit light on what he is doing and the kind of opportunities that is there for each of you in the innovative sector. Then apart from describing on the prototyping, practical side of the prototyping activities, what exactly is really required by an innovator when you are actually planning to convert your ideas into a prototype. So Dinoj, over to you. So I already gave a little bit brief introduction about Dinoj. So I'm handing over the platform to Dinoj to start a session. Dinoj, please.
Oh, yeah, finally. Sorry for the inconvenience caused because this Cisco platform was little, new to me. So sorry for that. I hope my audio is clear, right?
Yes, it is.
Okay, great. And let me know if the audio was bad or anything. Okay, yeah. Yeah, I will try to make up the lost time. So I think straight away we can start with the session. Okay. So before that, I would like someone to just brief about what all things has been covered today. Is it mentioned about the metal 3D printers, or can someone just unmute themselves and because I didn't attend the previous session. So yeah, in the meantime, I will just share my screen. So maybe Ashwin or Pranav, Rohit, someone. Hey, come on, yeah, someone.
Hello.
Yeah, who is this?
Trijo from Sri Buddha College of Engineering.
Okay, hi, Joe, right? Trijo.
Yes.
Okay. You are the department head, right?
Yes, IIC
Okay,
convener of
yeah.
Sri Buddha
Hi,
College.
Trijo. Yeah. Okay.
Actually, in the first session, we have seen 7 different methods of additive manufacturing.
Okay. So I think the plastic 3D printing, metal 3D printing, are those things covered?
Metal 3D printing, I think briefly has covered.
Briefly covered, right? Okay, fine. Okay, so what I would do is that I would just quickly tell you, tell you all how we are using 3D printing for rapid prototyping and for the live projects what we have. So before proceeding to the session, I would like to just give a few intro about myself and my company. I did my bachelor's in mechanical engineering. Then after that, with few years of work experience in petrochemical and flow metering calibration, I did my master's in industrial design from IDC IIT Bombay. So basically, I'm an industrial designer, and my core areas were electronic healthcare products and portable surgical solutions and all. So uh, we have we have formed a startup 1.5 years back, and its name is Mergior Private Limited. And what the activities we do is that we work on various. Yeah, you can see my screen, right? Someone? No?
Yes, now it's okay.
Okay, great. Yeah. So this is our company website. So maybe after a session, if someone is interested, can just go through it. So we work on portable solutions for surgical procedures and all. So there are a few projects what we do. And in the services section, we do a lot of product design related activities. So these are few of the products what we did. So as an engineer, probably we will be more focused on developing the technology or doing the calculations or predicting or those kind of things. So when it comes to industrial design, we also look about how to make these things more usable, how to connect the technology with the user. So basically, we try to add in more emotions to the product. Okay, so that's what we generally do as industrial designers. And we focus on the material, the manufacturing processes which are involved. And generally we call it CMF, color, material, and finish. So yeah, so these are the few projects, and we also do engineering calculations for arriving into those specific designs, because we cannot take science apart from design. Then another thing what we are doing are marine scale models. So in the last section you will find that out. All these things are 3D printed only. Okay, so I will explain you in detail how these projects are made. So before that, I want you all to be in the same page and to have an understanding of what industrial design is, and or what how the engineering knowledge can be used for designing more practical products. And the another services what we offer are 3D printing. Yeah, so we have machines, and you can see there are a few machines just behind me. And yeah, so now let's close this, and straight away let me jump on to the 3D printing PPT. Okay, so when we speak about 3D printing, most of the people will think about plastic filaments, being melted and extruded to get the 3D prints. So I would like to start the session with a relatively new topic, that is clay 3D printing. This is a very better example for understanding how this 3D printing funda works. So I hope, if possible, I would recommend someone to unmute and to have a conversation during the session, because yeah, the feedbacks will always, conversations will always make the session better one. So if someone need to stop me in between, feel free to do that. Yeah. So you can see this porcelain has been, or the clay products like pots, jars, or vessels, this has been in the market for really long time, right? Maybe the Chinese, I think they are most famous for the pottery and all. But the latest technologies actually help us to make this kind of masterpieces from a 3D model. So as you can see, the traditional methods of making clay products are by hand or by skilled artisans, right? They mainly use a wheel to get symmetric shapes, or they can use just like a freehand drawing, like they can mold the clay to get the desired shape. But if you see, the repeatability is the biggest issue in all this, and there is a lot of subjectivity which is involved. So if a artisan makes a pot, the skill of the artisan is very important, right? The subjectivity cannot be eliminated. So what 3D printing or the additive manufacturing techniques help is that it will help to attain the same level of perfection without the skills of such a experienced person, which is required in the field. So there are different types of techniques. So I'm not going to explain each and every technique in detail. If someone is interested, they can write down the name and later Google about it. There are techniques such as binder jetting. Basically, these clay particles can be fused and it can be solidified. And there are ceramic stereolithographic techniques which are available. I hope, like earlier sessions, someone might have mentioned about the stereolithography, where there can be certain kind of resins which can be used, and layer by layer these things will be printed. And this is the most simple and common way, by directly extruding the clay and making it onto the desired shape. To understand the basic FDM, filament deposition method, or the basic, here in ceramics we call it liquid deposition modeling. So basically it is something having a consistency of toothpaste or a dough. Okay, and this will be extruded from a injection module which is kept either in a delta coordinate system or a Cartesian coordinate robot, and this gives the desired shape. So you can see this I hope you all can see my mouse pointer, and this tip actually extrudes the clay onto the surface and it gives out the desired shape. But there are several manufacturing. Yeah.
Sir, your presentation is not visible, sir.
So right now it is in what you can see?
You can see that isolation unit is for burns treatment. I think it your
Oh,
website.
it has been okay, so you have missed quite a lot. So do you see the screen now?
Yes, yes.
So
Product
what you
design.
can see? Okay,
Product
great. I
design.
think we were actually exceeding the data usage. So yeah, I have asked everyone to stop using the net. Anyways, sorry for that. So if the screen doesn't go with my words, please let me know. Okay. Yeah. Pardon me for the inconvenience again. Yeah. Okay. So now probably you can relate. So these are few of the product design works we have done, and I hope you can see, right? You can see a hammer, chisel, and all, right? Someone please.
We can see.
Okay, yeah. So this is what I was earlier telling you about. These are the few of the works we have done. And the another thing, now you can see some boats, right? Images of the boat. Marine scale models.
Yes, yes.
Do you see that?
Yes, yes.
Yeah, okay, great. Yeah, let someone be there for constant feedback, or else, Okay, so these are the another things what I was explaining you about. So I will explain about few of the selective projects from this. Okay, so before going into those projects, I would like to explain you about few of the 3D printing methods. So as I told earlier, the filament deposition method by plastics, which are very common form of 3D printing, and which is the most widely used and the most affordable kind of 3D printers which are available. So if you see behind me, there are some filament deposition 3D printers, okay, running. So this clay 3D printing, as I was explaining about, this is the most easiest way to understand 3D printing actually. So see, before jumping on to 3D printing, we have to understand why 3D printing is important, or what are the advantages of 3D printing. We might have heard about complex geometries can be made, or it helps in creating certain types of designs which are almost impossible to do with other conventional manufacturing methods and all. But more than that, what I would say is that you can totally eliminate the subjectivity, because if a porcelain pot or a clay pot need to be made, who do you approach? Do we have the skill set to make a clay pot? Probably no. You need years of practice, experience, and the right tools to make that, right? But instead, if we can design that in a computer, or maybe if we download that from some softwares, I mean some websites like GrabCAD, or some websites what gives the 3D printable models for free, what we can do, we can straight away do the 3D printing, right? So here we are avoiding the subjectivity. So that is something very important, because each time we can assure we are getting something really accurate. So you can have a master model what can be 3D scanned and brought onto a computer, or you can have something directly made in computer and which can be prototype, right? Okay. So as I told, there are different techniques by which this thing can be made. So I would recommend maybe whoever is interested to write down the names of the process, and later you guys can Google and figure it out. The binder jetting is one of the most common ways. Then there are ceramic stereolithographic methods. Generally, in conventional processes, they use a specific resin, and this resin layer by layer is converted onto a 3D printed object. Okay, so I would recommend to write down these names and later Google it, because the time is really limited, and it will be very difficult to explain each of the processes in detail. And there is the common liquid deposition modeling. So this is very similar to the regular FDM method. So I hope you can see a screen where it is written liquid deposition modeling, right? If you cannot see what I am speaking, someone please let me know that. Okay, yeah. So the liquid deposition modeling, it can be very much related to the filament deposition method, the FDM 3D printing. So imagine the regular the toothpaste canister. So morning when we brush the teeth, what do? You just squeeze the cartridge, right? The toothpaste cartridge. So then the toothpaste is extruded out of the nozzle. The process is very same. You make the clay in such a consistency, it can be extruded just like a toothpaste. And what if you are giving this toothpaste canister onto a delta coordinate system or a Cartesian coordinate kind of CNC machine? What it happens? You can very precisely move the thing, and you can get the desired shape. So I hope you can see my mouse pointer here. Each layer, how these layers are formed, one after the other. This machine will extrude a fine layer of clay, which will be adhered to the previous layer, and that is how the entire shape is made. So this is something very simple, and I would recommend, maybe someone can try it out in your college by modifying an existing CNC machine, or you can even have this kind of extruders fitted onto basically a piston cylinder extruder fitted onto the regular 3D printing machines to make something like this. Okay. Yeah. Then another processes are like nanoparticle jetting and all. So when we speak about ceramics, these are not really for making a porcelain pot, but of much superior objects. Yeah. So as I told earlier, there are several FDM to LDM conversion kits also available. So you can see this is nothing but something similar to a toothpaste canister. You have a piston cylinder arrangement here, and you have a geared motor here, right? And there is a nozzle. So if you connect it and if you fill the cylinder with clay, you can straight away extrude the clay, and you can do the printing. So most of the designs are open source, and almost everything is available in internet. If someone is planning to take it up as a project, it has got good market. Yeah. So you can see someone has converted use the same mechanism and convert a regular syringe onto a clay printer. So this is a regular FDM printer, and he have used some servo motor to give that actuation, and you can see how this thing is printed. So these are not pretty accurate models, but yeah, anyways, worth trying, I hope. So then instead of putting the clay, what if you are putting some chocolate or peanut butter in that? You can actually 3D print food, right? So this can be one good technique where maybe some hotels or restaurants will be willing to buy such a machine, right? Anyway, it's very interesting. Yeah. So then if you look about the future of clay printing, more and more research is required in this domain to get a proper clay with proper consistency, because the clay what we get in maybe in our demographic region like in Kerala will be very different from what you will get in Rajasthan or in Gujarat, right? So standardizing this is a bit of a difficult task. So it needs a lot of research, and it needs lot of modifications in the 3D printer itself. Okay. Yeah. So now coming to the SLS 3D printing. So SLS 3D printing means basically there is a powder, okay, and that powder can be transformed onto something of desired shape. So what do you all see? Do you see the slide where it is written history of SLS 3D printing? Can someone give me a feedback? Great. So, and I hope all of you can see the slide where it is mentioned as history of SLS. Yeah. So now you imagine, imagine some sawdust or cement powder spread on a plate. Okay. And you are pouring, or maybe you have cement placed on a table, and it is spread across the table, and you are pouring some water in a specific shape. What will happen? Maybe after a day, that area where the water is poured will be solidified, right? Okay. Or what if you are putting some super glue on that powder? What will happen? That will immediately get solidified. So after one layer is formed, you are again pouring some powder on top of it, and you are repeating the process. So maybe after an hour, or maybe after like 1,000 or 5,000 times doing the repeated action, what you will get? you will get some solid
Dinoj,
shape.
Dinoj, sorry for interrupting.
Yeah.
Dinoj, yeah. There is some, it seems there is some problem with the slides you are projecting.
Okay.
Are you looking at a slide called marine scale models now?
No.
No, what we are seeing here is marine scale models. You can go to share in that down, the buttons, and please select share from that and take your whatever screen you want to share from that one. Yeah, now it is history of SLS 3D printing. Is that what you are showing? Now we are not able to hear you.
Muted. Okay,
Yeah,
now you
you're
can
okay.
hear me, right? Okay.
Yeah, now we can hear, we can see the
please.
history of SLS 3D printing. Is that the slide?
Okay. Yeah, that is a slide. And
All
what I
right,
would
fine.
recommend is like someone can maybe someone can unmute and be there to give a feedback, because I have been showing a lot of slides afterwards, but I don't know why it happened. Okay, maybe I won't keep it full screen. Maybe I don't know if that helps. So what do you see now? History of SLS 3D printing. Is it that?
Yes, history of SLS 3D printing.
Now it is two SLS 3D printing applications, right?
Yes.
Okay, great. So maybe I won't make it a full screen. Yeah, because I think it's the first time I'm using this Cisco platform. Yeah, so I don't know if whatever I am speaking and the slides doesn't match, please someone just notify me that. Okay. Anyways, so I hope my audio was clear and all of you got a kind of understanding what these SLA machines are actually doing, right? Basically, they convert some powder, okay, to what? To a 3D shape. That is what these machines are doing. Okay. So as I was explaining the cement water example, so now imagine you have nylon powder or ABS powder, okay, and there is a laser, and this laser actually melts the powder in a specific shape, specific 2D shape. Then after that, more powder is poured on top of it, and again the process is repeated. So thus layer by layer you will get the shape from a what to say, a vat of powder. So that is what the process does. So you can see this is, you can see a casing of the drill machine, right? I have the slide. It is like engineering, rapid prototyping, mock-up for product. Do you see that? Hello.
Yes, it is okay. In between, there was
Okay.
a small break. That's all.
Anyways, fine. Yeah. So these kind of designs, very accurately it can be made. So if we compare the regular filament deposition method with the SLS method, the SLS printers are little expensive. They start from a price range of like 10 lakh and above. So if you are planning to print something like this in FDM, the filament deposition method, which is melting the ABS or PLA filament and making a shape, these are going to cost at least 4 to 5 times compared to an FDM machine. Okay, but the accuracy will be good and there won't be any issue of the support structures. I hope you all are a little bit familiar about the support structures and all. If not, then I will show that in my subsequent slides. Okay, now I have changed the slide. I have mentioned it as manufacturing. Okay, so as you can see, automotive industry is widely using this kind of SLA 3D printing machines for prototyping. Yeah, in healthcare as well. So this is actually a more mobile near me, so I can see whether the slides are changing or not. Anyways, so in medical prosthetics and all, they are widely used because it will give very clean and neat print, and the strength of it is really good. So we can have engineering materials such as nylon and nylon like materials. So these prints will be pretty decent and strong. So I hope you might have seen this kind of images in Instagram or maybe in internet, right? So yeah, but so here I have a question for you all. So if a person breaks his left hand and the hand is actually swollen, okay, or it is injured badly, and if such a cast has to be made, so can you suggest how this can be made possible? Basically, we need to get the 3D model of the hand of the person, of the injured person. But the hand where you are going, you need the cast is already injured. So then any idea like how to make this or how to design such a splint? Someone, I want all of you to think. Or just imagine like how these things will be designed. So if I am giving you maybe some college this project, so how do you actually do that? How do you design for this? Anyone? Okay, since no one is telling anything, so maybe I will give the answer. So how these things are made is that um, I hope you all have seen, I mean, heard about CT scan or MRI scans, right? So in CT scan, how they are doing the CT scan? They take X-rays, right? There is a certain machine which takes multiple X-ray, and what you will get is that in X-ray we will get the bony prominences or the bone structure we will get, right? Then there is another thing known as MRI. MRI, what it will give you? It won't care about the bony structure, but it gives about the other parts of the body, like wherever there is water content, it will give a very clear image of that. Okay, so to make very accurate models, what actually it is done is that X-ray and CT scans are combined. There is a file known as DICOM. These files are combined and a 3D model is generated. Generally, they are generated in STL format. So if the left hand is injured, probably the human body is kind of symmetric, right? So the right hand CT or MRI is taken, and from that, a cast is developed and it is mirrored. And for some people, there will be very prominent differences between both the hand. So in those cases, these models can actually fail. And practically at IIT Bombay, when I was working, we had tried making something like this, and it was not really that effective. So we were actually making something for the leg, and later the patient has to be done a regular cast. So this technology looks interesting, but lot of research and improvisation need to be there. Okay. So when we speak about 3D printing, we have to be very clear about what are the issues or what are the shortfalls of these processes. Okay, yeah. Then another thing what I want to explain is about vacuum casting. I want all of you to write it down, the process known as vacuum casting, because I haven't seen this process being explained in engineering textbooks. So this method is one of the easiest way to make multiple models, in the sense for batch production. Imagine a situation where you have to make, this is a bicycle brake pedal, and I hope all of you can see bicycle, sorry, not the brake pedal, the pedal of the bike, okay, the cycle. So you can see a lot of bicycle pedals stacked on top of other, right, in a box orientation. Okay, so if you want to make 20 of these pedals, can you all think what could be the uh, potential ways of making it? If someone can unmute and give me an answer, that will be great. Or else just think, if I want 20 pieces, definitely 3D printing is a way, but if you want to make, then probably it will be very expensive. It can exceed like 3 or 4 lakh rupees if I am doing SLA or SLS printing. It can exceed if you want it in very quality material. So in such cases, vacuum casting is actually widely used. So vacuum casting, how it works is that yeah, imagine like if you want to make the replica of this spoon. So what could be the potential ways of making this spoon? 3D printing, definitely. Other than that, you can go for CNC machining, right? But CNC machining, plastics very thin shape and size will be difficult. So how we does is that we 3D print a highly accurate model of this spoon, or the earlier example, bicycle brake pedal or whatever. And afterwards, what we do is that we pour some liquid resin on top of this. And from this liquid resin, what we do is that we make a cast, or we make a mold. In this mold, we pour certain liquid resins, mostly polyurethane based or silicon resins. There are a wide variety of resins which are available. And after that, we place that in an oven, and we will get the identical copies of the product. Okay, the process is little difficult compared to the other subtractive manufacturing processes, but it gives very good results, especially if you want to make some thin fragile plastics. Okay, so I hope everyone has noted this name, vacuum casting, and I recommend everyone to read about it. Or there are enough YouTube videos available. You can just watch how this process is actually done. Okay. So definitely there are some other exotic kind of 3D printers which are available in market, and some are in research state. So there is something known as ICE 3D printing. Have anyone heard about it? At IIT Bombay Mechanical Department, they have got a fantastic machine. So that is an ICE 3D printer. So what it does is like, what if we are 3D printing with water, pure water, distilled water maybe. And as all of you know, if you print at room temperature, probably you will get a pool of water, right? Nothing else. But what if we are printing it at sub-zero degree? What if we are printing the entire thing? We are keeping the entire printer in a refrigerator freezer at sub-zero degree. You can literally print with ice. So this, if you go to IIT Bombay, I would recommend to visit the mechanical department and to see this machine. So what they have done is that they have actually converted some sort of regular inkjet printing head to such a printer. Okay, so that is really possible, and there are plenty of research papers available. Maybe someone of you can, take it up as a project. It's very interesting one. It is very much doable. So if you see what are the applications of it, this can be used for making pattern for metal casting. That is a good way of doing it. And yeah, and ice sculptures people are making about. But anyways, there are not any very specific applications which has been developed so far for this specific printer. But anyways, very interesting. And sand printing. What is sand printing? Sand printing, there are two types of sand printers. I hope you can see a solar cinder machine. Do you all see the screen? I hope you all can. If you can't see a desert with a Fresnel lens array and with a bunch of solar panels, let me know. And person lying on the floor. So this is a very interesting printer developed by a German designer. So what he does is like, he uses sand, regular sand in the desert, and he uses a Fresnel lens to convert the entire solar energy onto a single point, and by which you can literally melt the sand. And the sand is melted and you can do some 3D printing. It's basically some sort of, sculpture, or it's kind of an art, not really something of any practical use. But we don't know. Maybe in future someone comes up with a very interesting idea how to use these things. So this port is actually made by this sand printer. So this is like literally molten sand. So you can see how he have made the setup. There is absolutely no energy consumed other than everything is 100% green because solar panels and these things are being used. Okay, and the entire heat for melting the sand comes from this solar radiation from the Fresnel lens. So, and to get an approximate idea, like 600 watts, if you have a lens of say 1 meter square, it gives an approximate heat of say 600 watts. So that if entire thing is concentrated at a single point, the temperature really rises. So here I have mentioned again about a sand 3D printer. So this sand 3D printer, how it works is that it actually works on the principle by binder jetting. So this binder jetting, you have heard this name earlier in the clay 3D printing, where the ceramic 3D printing was there. So what it does is like, you have the regular sand, you mix the sand with some sort of polymer. For example, if you are mixing that with some ABS, PLA, or some kind of plastic, and you have a laser on top of the machine. You have a laser, okay, and this laser is radiated on this sand in a specific fashion. So what happens is that this polymer which is binded, which is coated on the sand will melt and will fuse together. And once the process is done, what you will get? You will get a block of sand, or in the sand in the desired shape, which is not really melting the sand, but the binder plastic will be melted and fused together. I don't know whether my explanation was clear. Okay. So it is something similar to, I hope all are Malayali. So, നമ്മുടെ കപ്പലണ്ടി മിഠായി കണ്ടിട്ടില്ലേ? കപ്പലണ്ടി മിഠായി, how it is made. So you have the peanuts, and on top of it you put jaggery, right? Molten jaggery. How then what happens? They fuse together to form a certain shape, right? So this is something very similar to that. Instead of pouring the binder or the jaggery, you pre-coat this peanut with jaggery and you put in a vat, and you use a laser or a heat source to melt the jaggery and diffuse together. So maybe some of you can try it out. I hope it is clear. Then there is something known as wax 3D printing. Wax 3D printing is again a very interesting method. So can someone guess like where these wax 3D printing machines will be used for? Someone, I want someone to unmute. Someone, at least I should know, like someone is listening to me. And I don't want any faculties to unmute, okay, please. I hope this session is for students, so yeah, or else it won't move from this slide. Adi Shankara College, there are participants, right? So maybe someone from Adi Shankara College. Hello, hi, someone from Adi Shankara? Or I will ask Professor Trijo to call his favorite student. Professor, do you want to try that? Hello, sir. Are you there?
I'm here.
Yeah, so maybe you can call your favorite student. I just want someone.
Pranav, are you
Please.
there?
Yeah, Pranav. I cannot see the participant list, or else I might have myself called out the names. Is there anyone else? I think someone is trying to speak. Who else is there? Which other college is there? Maybe some. Can someone tell me like which all colleges are there? I think Shravan is trying to speak.
The first thing that came to my mind after listening to that word is just the 3D the wax models of Massachusetts. Yeah.
Okay, so what do you think? Where these wax prints will be used? Where we use wax for? We use wax for candles, right? And the honeybees use it for waterproofing or closing their, beehives, right? Okay, so where it will be used? What do you think? And I haven't heard about the wax model of Massachusetts. So can you explain what it is? It's like a new information for me. So,
The realistic models of celebrities and famous personalities.
Oh, okay. The wax models. Wow, great, brilliant. Oh, I haven't thought about 3D printing using wax for doing those sculptures. That can be a good idea.
It's too massive, right? I don't know.
No, it is massive, but it's a good idea. Which college you are from?
Sri Buddha College.
Oh, great. So why don't we start a project for making the first 3D printed wax sculpture? We have a mission which is compatible for 3D printing. Why don't we try that?
Okay. I will ask
Right.
Rijo, sir.
Yeah. And maybe you can contact me after the this meeting. That's excellent idea. I haven't ever thought about that. Yeah, brilliant, man. Come on, great. Okay. See, you don't really have to make the entire wax sculpture, right? You can only print the parts like face or ear or something like that. because I will tell you 500 gram of this wax resin cost around 14,000 rupees. So that is going to be really expensive, right? But you can check what is the cost of this wax statues. If you want to make your wax statue, then how much will be the approximate cost? You can just check that. And how many days does it took? Okay. And if you can 3D scan your face, there are plenty of 3D scanners which are available. Even the Apple latest Apple phone or the tab has got a 3D scanner, but they are not that accurate. But you will get a lot of 3D scanners. And there is another technique known as photogrammetry, where you click a lot of images and you can stitch them together to make a 3D model. So that 3D model can be imported to softwares like Blender or Rhino and all to create the fine details. After that, it can be straight away 3D printed in the SLA machines. We also have these SLA machines. Excellent idea. So I think it is worth taking it forward, or at least see what is the possibility of doing it. Okay. So another, can you give one more guess from this image? You can see a lot of things, orange things on a platform. What do you think they are?
Items, decorative items.
Decorative items?
Okay.
What sort of decorative? Arey, yaar, come on.
Okay.
It is so obvious. Someone help him, please.
Miniature human sculptures.
Arey, dude, this is not human. This doesn't look like a human. It's what? It is something on your hand, not your hand, but probably
ring. Is that ring?
Yeah, it's a ring. Yeah, man.
Oh,
great.
Okay.
I don't know. Okay, it is a ring. It is a ring. So, have you seen such complex rings in the market?
No.
Okay, so these things are there, but they are really expensive. So, if such rings are not there in the market, then why don't we start making it? Definitely, if you go to any jewelers, any gold or silver jewelers, what they will have? They will have all those sort of traditional ornaments, right? But what if we can 3D model a new jewelry? And what if we can 3D print that? That is possible. And that is what the wax printing is mostly used for. There are materials such as sterling silver. So these sterling silver jewelries are widely available by 3D printing. So how it does is that, how it is done is that the models are 3D printed by wax in SLA 3D printing machines. There are certain kind of 3D printers which convert resin to a solid object. They are known as SLA 3D printer. So here it is mentioned SLA. Okay. I would recommend everyone to go through that. Anyway, I will be just briefing or showing with images of SLA 3D printing. But I am very sure after session you all will forward. So at least write it down. Maybe, when you don't have nothing, you don't have anything to do, you can just Google about it. There are a lot of amazing videos. And if there are not enough videos, try making something yourself. Okay. Yeah. And how this wax is converted onto a gold jewelry. So what is done is that these wax rings will be connected together in form of a tree, just like a Christmas tree actually. And there is a process known as lost wax method. I hope you all might have at least heard about it during your engineering sessions. If not, then there is something terrible wrong with the syllabus. Lost wax method is one of the ancient methods by which the casts are being made. So you make something with something like wax, which is which can be easily melted, and you pour ceramic liquid over it, and you allow it for drying out. Then you have a ceramic mold, and afterwards you have to heat it in an oven. Then what happens is that the wax will just melt and leave these spaces inside, leave these complex 3D forms. And afterwards, what you do is that you pour molten metal into this cavity. Okay. So for making the cavities, actually we are using 3D printing. Since these are very complex and very difficult to make it with hand, you go for this 3D printing. Right. Yeah. And afterwards, this mold is cracked and it is taken out, and it is polished, and whatever the gemstones will be attached on top of these rings. That is how it is made. So you can see these molds we are creating are kind of a temporary mold. You cannot repeatedly use it. So if you have one design, each time you will have to do the 3D printing. Since in Kerala or in India, these things are there, but not that widely used. So it is a domain what we can actually explore. If someone is into jewelries, or I'm very sure, like at least someone will have some relative who has got a gold jewelry or a silver jewelry, or into making of these gold ornaments and all, they can actually try out something like this. We are actually doing this wax 3D prints in house. Okay, and we have got some vendors. So slowly these things are getting gained. This is the beauty of engineering. Once you know engineering, then we can substitute or find better solutions for the day-to-day stuff. Okay, so this is the actual beauty of engineering and understanding prototyping. Whatever I have explained are methods of prototyping, right? I hope all of you will agree with that. Anyways, yeah, thank you very much for your participation. Okay. This is what, when you open your mouth, you get businesses and ideas, right? That's interesting. Okay. Then 3D print using A4 sheet. What is that? A4 sheet 3D printing. Again, someone else. I want someone to guess. Even the same person can, if you want. This can be another business for you. Yeah. Someone. Your name is Shravan, right? Do you want to give it a try?
You mean printing on
This is the
A4
topic.
sheet?
3D printing using A4 sheet, not on A4 sheet.
On
What do you think? How you can make a 3D shape using A4 sheet? One way is origami, or there is kerigami, right? Origami means you fold something and make a shape. The second way is what? You cut the A4 sheet into different shapes and you glue them together using a PV adhesive or using a sellotape. അതല്ലെങ്കിൽ ചോറുമറ്റ്, right? So how do you do that? Or what it will be? What is the other way of making a solid geometry using A4 sheet? I want everyone to think. I'm very sure like someone will be thinking and having the answers already. Maybe a little shy, or don't want to express themselves. That's also fine. I respect everyone. Okay. So any guess? Okay. Imagine you want to make a sphere from A4 sheet. Okay. And you have a sphere and you chop that sphere into maybe multiple layers. If it is a 10 centimeter diameter sphere and you have A4 sheets of, say, what is the thickness? 0.2 mm maybe. So 0.2 mm A4 sheet. So how many A4 sheets you will need probably? You will need a lot of A4 sheets, right? Can you do a quick math? How many A4 sheets it will take? 10 centimeter. 10 centimeter means 100 mm, right? So 100 mm 0.2. How many it will take? 500 around? Okay. So we are laterally splitting these A4 sheets. So if you split a sphere into sections, what you will get? You will get circles, right? Are you able to understand that? If you split a sphere diametrically, what you will get? You will get a circle, right? If it is a hollow sphere, you will get a circle. And you cut that circle using an A4 sheet. And after that, you will, if you go one layer above that, what will happen? You will get a circle of a lesser diameter. So like that, you cut the A4 sheet in various diameters and you stack them together. So finally, what you will get? You will get the desired shape, or in this case, it will be a sphere, right? So this is the way in which this method is, I mean, laminated object manufacturing. This, I want all of you to write it down, laminated object manufacturing. Yes, Ravan, were you able to understand? I hope that was not a great explanation.
Yes, sir.
Huh? You got an idea, right? Yeah. Okay. By the way, you can call me Dinoj because at your age I was sitting just like you, so it's fine. You don't need to call me sir. Okay. So then, how do you glue the stack? Make sure this you are getting the desired shape because you need a binder for it, right? Imagine you have got two layers of paper stacked together. You need to put some glue in between. So that is what it is written here. Layer by layer of paper is cut and glued together to make a 3D object. Okay, so this can be a much reputed use of scrap A4 sheets maybe. And how these A4 sheets are cut into this desired shape. You can use laser or you can use the regular CNC plotting machine sort of head. That is one way of doing it. And another idea is that since it is A4 paper, regular inkjet printers can be used, and this inkjet print head is added on to the 3D printer, so you can get any color on the color for 3D printing. Earlier, I had explained you about SLS method, where a powder is converted onto a 3D shape. In that process, the powder can also be colored using the same way of making it. So these printers are basically a combination of, this is a very good example for cross-pollinating different ideas. For example, you are getting the idea of coloring it from a a laser jet printer, and you are getting the cutting of A4 sheet from a CNC plotting machine. Plotting machine, right? That's what you call, right? Yeah, the vinyl cutter or the vinyl plotting machine. Okay, and you have the simple gluing technique by which we glue two papers together. That is again, some sort of CNC control thing. So that part comes from the regular FDM machines or a regular 3D printer. So this is a very good example for, example for what? Example for cross-pollinating or combining ideas. Definitely, this has got drawbacks, like not all shapes can be made. If the paper part is so tiny or so small, it is difficult. And another issue is that lot of A4 sheet wastage happens during the process because you need a A4 sheet, A4 in the sense a paper as large as a print bed. So that is how this process is done. You can just Google and see how this is actually happening, and you will get a idea. Even if we say waste paper can be used, it again creates a lot of waste paper where someone else need to create another technology to use that waste paper. So generally it is not so eco-friendly technology, but yeah, you will get some awesome paper product. Anyway, thank you for your participation. Then what if there is no gravity? Again, Shravan, I don't think anyone will speak. If someone want to speak, please, you will give some rest to Shravan. So zero gravity. So all these 3D printers we have been explaining when there is gravity, right? What if you take a metal 3D printer or an SLS 3D printing machine or an A4 printing machine or any machine or a resin 3D printing machine to a zero gravity atmosphere? Simply the powder won't stay there, right? If it is a resin, the resin won't stay there. FDM machines can work because that doesn't really depend upon gravity. Yeah. So what if the International Space Station, I hope like everyone knows about International Space Station, and this is something what you can actually see from the Earth. And there is a International Space Station tracker what you can download in your phone, and it will notify you when this thing is going over your head. Okay, so it is an interesting thing. So in that, they need to carry a lot of tools or a lot of equipments. So isn't it a good idea to get a 3D printer into this ISS space station, and they can actually 3D print the objects what they want? What do you think? Is it a good idea or not? Someone? Sijilin Givargis has just joined. So maybe, or Shravan, anyone. What do you think? Have you heard of this technology? Okay, so if you haven't heard it, it's a good idea, right? Then why can't you float this kind of problems for for your academic project? Why you all still want to do some material characterization or some Insta thing what you see and just to replicate it because no one else has seen? You don't really have to do, right? Okay, so see, basically what I'm trying to say, we need to explore, because engineering is not a joke. Engineering is something very interesting, and the knowledge we have we should have to do the proper engineering projects, that is really huge, because almost all fields are kind of getting saturated. So before moving on to a new technology, we have to be very sure what are the existing challenges, or what are the existing problems, or what are the existing innovations which is done in this field, right? Yeah. So they are using fused filament fabrication technology, filament extrusion basically, because SLS or resin type things cannot really done. So can you optimize something for this specific application? We are even planning to go to Mars, or to capture. Maybe why can't you have a project which is associated with ISRO? So we can develop these kind of things. When we tell about the space research or astronomy with this 3D printing, often people think about 3D printing rockets, what Elon Musk does, right? But there are a lot more things what we can do. Maybe what if you can 3D print food, because in space station it is difficult. And what if you can 3D print tissues, because in biomedical or in tissue culture, whatever things, these domains, it will be applicable. So these domains has to be explored. So the term 3D printing itself shouldn't limit you from jumping on to other domains. Yeah, zero gravity 3D printer. Yeah, sorry for that. This is a wrong heading. And have yeah, this is actually a good tool to see whether you guys are listening or not. Okay, it's not zero gravity 3D printer. This is just a food 3D printer, and having a wrong topic. Yeah. So I will just show you some 3D printed objects what we have done here in the past few weeks, done basically done by the interns. They have done some really fantastic work, I would say. So all these models you see here, they have learned 3D printing. I haven't guided them. They have learned 3D printing. These two objects are made using, this is an earring by the way, and this is some Pikachu or some Pokemon or something. I'm not a big fan of Pokemon. Anyways, I hope this thing will be familiar, right? We are actually planning to sell it. If any of you want, just message me. Yeah. And we have renamed it as Ulichatan, by the way, so that we can make it, more, relatable. And yeah, these are again some Pokemon characters. So this is something known as cityscapes. So how these things, I think some of you, if you Google for city frames in Instagram, you will find some interesting channels who actually print these cities across. So how do we get is that there is a software known as Blender. In that Blender, you can actually get the height information of buildings from what? Buildings from Google Map. Okay, that information can be brought down to this Blender using a plugin, and you can actually generate it. So this is not something what we invented, but it's already there, and I recommend everyone to try that. And these are done by FDM machine, and you can color it and you can put some lighting to give some spectacular feel. And we are actually selling it. So if someone wants, yeah, please, again, some marketing, high-end marketing. So these are again, some other parts. So this is one of our intern, Mr. Vedas. So he is a brilliant engineer and the youngest one in our team. He is just second year, and his interest towards 3D printing and additive manufacturing had helped me to us to gain a lot of traction in the field. And yeah, I hope like he also have gained a lot. So this is something known as just a minute. Lithophane, right? Yeah, lithophane art. So there are websites. If you just Google for lithophane, you will lithophane 3D prints. You will get a lot of websites who give. If you give a photo, they will give this kind of lithophane model. So they are basically FDM 3D prints or SLA 3D prints where it has got some height. So if you put a illumination behind, the thicken areas will be darker, and the less thick areas will be brighter. So that gives a very different, unique feel for this images. So this is something what you can actually try out and communicate 3D printing to your juniors or for someone who doesn't know 3D printing, right? Okay. So again, thank you, but I'm not going to leave you guys because I have one more PPT to show you all. But do you have any doubts considered to this PPT? Feel free to ask till the time I take the next PPT. Someone, I want someone to ask some doubt. Okay. If no one is there, I will again gonna ask Shravan. Oh, there are some Givargis, I think, joined earlier. I have no clue like how to take the participant list, or else I might have called you all by names. Ashwin, is Ashwin there? Audible? Or Baiju? Sorry if you guys are faculty, because here it is not mentioned like professor or any, no suffix prefix is there. So Hemant, someone? I need someone to speak about it.
Hello.
Yeah. Yes, who is this?
Hemant.
Hemant. Hi, Hemant. Where are you from?
I'm from Pathanamthitta,
Oh,
Sriputra
nice.
College.
Sriputra College. Okay, great.
Okay, can you explain me what is the first image representing the 3D model?
Which one?
That black
Oh,
one.
dude, that is confidential. I cannot. Sorry. We have an NDA. That is a part of
Okay,
a
okay.
model. Okay. That is a part of a
Okay.
model. So sorry about it. Is
Okay,
there
okay.
anything else what you want to ask? Yeah, I think you have been really observing so close. I was happy to see, someone really
Okay.
paying attention. And this is a very good attitude what you should all have, Something, if you didn't understand, feel free to ask. But maybe if you can give your contact, once the project is done, I will share you the final image and everything. Yeah, sorry for it now. Okay.
Okay.
Yeah. So I will tell you, like, if you want to make something of large scale, okay, huge scale, I will show you. That is what exactly coming in the other slide. You can actually think of chopping the 3D prints and making it and later attaching it. Okay, I will show that. That is a very interesting thing what you asked. I will explain that in the next PPT about a very important tip what will be very helpful. Yeah. Anything else? Okay, if not, we will move on to the next PPT, and that is about. We have 15 more minutes, right? Okay. Yeah. Yeah, there is actually, yeah, I think this is not the PPT I was supposed to show you, but anyways, let me show this as well. So I hope you all are aware about the filament deposition machines. Okay, where you have got a Hari Krishnan, do you know about the filament deposition 3D printers? Hari, are you there? Or someone, please. Professor Trijo, like, I hope your students are aware of the FDM 3D printers, right?
They know
This
the
is normal
basics.
3D printing machines, right?
Yeah, normal 3D printing, regular 3D printing machine. Yeah,
Okay,
yeah.
okay.
I think Hemant has answered. Thank you, Professor Trijo. Okay, thank you, Hemant. Yeah, they are the regular 3D printing machine, but there can be something like what you guys are not giving attention to. So maybe you will be using head of PLA, polylactyl acetate, and I think it's polylactic acid or poly. Yeah, poly acid, right? Yeah, it is polylactic acid. And I think it is biodegradable. Then you have ABS. These are the two common things what is being used. Then you have got something like PETG. So if someone can take a screenshot of this slide and Google about what are the different materials available. So PETG will give you a little gloss finish. First of all, the PLA is the easiest to print. You can print without an enclosure or anything. But if you want to print ABS, you have to put a lot of glue on the hotbed, and you have to put inside a cover, and the temperature has to be really regulated. Especially you have the rainy season, the monsoons are here in Kerala, the 3D prints can act really weird. Okay, that is mainly due to the absorption of moisture to the filament. And again, if the humidity is not really controlled, there can be uneven heat distribution. So it has to be very much contained. And the filaments, once you have used it, make sure you are keeping it in a very dry place with some silica gel or copper sulfate, or if nothing works, put it in rice or something. So it basically you have to make sure it absorbs moisture. Okay, then PETG will give you a gloss finish, but nothing so great about it. Yeah, then there is something known as TPU. Again, flexible material similar to, I have missed the remaining part. Okay, pardon me for that. The TPU is a flexible amendment, basically polyurethane base. So what it gives is like, it will give you flexible prints. Okay, so if you are making layers of this thing, you can actually make fabric or any kind of clothing out of it. And it is very easy to use heat to combine them together. And ABS resin, I mean ABS 3D print, if you are printing it, you can actually use acetone to make it little cleaner, but never ever use more acetone or pour acetone directly onto ABS, because it can spoil the entire print. And the acetone should be of very high quality, probably 99.97%, because 99.99% is very expensive compared to 99.97%. Okay, and make sure you bargain very well with the chemist, because they have got like enough and more margin, like, you know, 1 5-liter bottle itself has a margin of like 500 to 10,000 rupees kind of. So make sure you bargain very well, or we can provide. We have like very good vendors. Okay, then you have carbon fiber filament. So carbon fiber filament, when I say that, it doesn't mean like there is a long strand of carbon fiber which is extruded, and it's never like that. It is more like you have a base filament, generally of plastic, and you have got these carbon fiber particles or whatever to increase the strength. Okay, here I want to explain something like, if you have a very flexible material, what are the ways to make it more strong? What do you do? The simple way is to add more fibers onto that. So you all might have, you know, seen the fiberglass FRP or GRE pipes and all. I don't know, glass reinforced plastic, resin reinforced plastic, and also generally it is like you have this resin, epoxy resins. You mix fibers into that, then basically the properties enhances. The thing becomes more strong but brittle, right? Even the F1 car, Formula 1 car, if it crashes, it breaks, right? It is not like a flexible rubber. It's not like a flexible rubber, right? So that is the advantage of adding fibers onto that. Okay, maybe someone can have some sawdust printer someday, because you can print the scrap sawdust with, you know, some kind of plastic and make a new material. Nothing like that, and we can say like it can be partially eco-friendly or something. Yeah, anyways, then there is something known as PVA filament. What it does is like, if you have a printer with multiple extruders, you have the parent material as ABS or PLA or PET or anything, and you have the support material printed in PVA. You can just put this thing in water and it just dissolves. And another way is that there are sodium hydroxide vats available, which has got ultrasonic transducers, which agitates the entire liquid violently. I mean, at an ultrasonic frequencies, not violently, ultrasonic frequencies, and it can dissolve the this kind of specific filament. Such kind of printers are also available, because I am very sure whoever has done the FDM printing, it is a mess to remove the support materials, right? So these techniques can come handy. Then there is metal filament. Metal filament again doesn't mean you have a long metal wire which is melted and, you know, at some 1,200. It's never like that. You have got regular plastic filaments with metal powders inside. So once the print is done, you can actually keep these models in some oven, and you can heat. So the plastic goes and the remaining powder shinders. So that is one way very easily we can make the metal prints. You don't really have to go for metal 3D printing machine. I will tell you an example. So earlier example, you know, the 10 centimeter diameter sphere. If you want to go for metal printing, you will have to spend some 50,000 or 70,000 rupees for just a single print. It can go even up to 1 lakh rupees. You can get it in titanium, stainless steel 216L, or, you know, any 304 or anything like that. But if you want to have it in some brass or something like that, then you can just get the metal impregnated. It's actually metal impregnated 3D printer, 3D printing filament, and you can use a regular FDM printer and do the print. Okay. Then the wood filament, as I told, yeah, wood filament, wood dust. There are even PLA-based filaments which are coming, which will be having the color of wood, but they won't be actually wood. So not all wood filaments are really having wood dust or anything. So they are sometimes, you know, just colored to have that that specific thing. And China is the largest exporter of the 3D printing machines and, you know, these materials. And there is a good scope that, you know, someone can take the filament making machine as a project and, you know, do that. Even if someone makes a good machine, then I am going to be your customer. So think about it, whether you can, you know, make something like that. Okay, so these are the, if someone want to take a screenshot, feel free to. ABS, polylactic acid, and yeah, then these are the kind of, you know, PVA or whatever. So here you can see the PVA thing. You have the support material in a very different color, right? Some yellow color or here a white color. If you put in water, it just dissolves. So this can be one good technique. Then the wood filament. Then this thing, metal filament at the base. So that is actually, it gives a metallic color. This is not really metal, but it gives a metallic shape. But in the top, it is more like if you heat it, then the part goes and it gives the metal alone. Okay, so these pictures are slightly misleading. Anyways, any doubts? If not, I am again going to bombard with more and more slides. Someone, Hemant, do you have any doubt? No? Okay. Now let's, I hope you have seen this marine scale models, right? So here I am going to tell you, this was one project we got recently, just few months back. One of the client, a very good client from Cochin, because he was not having an engineering background, but still he was willing to give this project for a industrial design firm or for 3D printing. In the first meeting, when we explained about 3D printing and all, he was totally alien to the thing. But when we explained it in detail and all, actually it helped us a lot in gaining more traction in this domain. And he finally convinced to go with the 3D printing the technology and all. Because okay, so I hope you might have seen at least some images of the Kozhikode and Uru, or some sort of ship models, at least in airports or somewhere. Okay, so have you ever imagined how these things are made? So if you want to have like 1 meter long marine scale model, a miniature model of a ship, mostly it is handmade using wood, forex board. Forex boards are basically PVC particle boards only, or similar materials. So the issue is that it takes like 4 to 6 months, and it needs a skilled person to do the job. So what we did is that we did a 3D modeling in Fusion. I hope everyone knows Fusion 360 is free for students, and for startups it is absolutely free. And it's a fantastic software. But when you try to create large models in true scale, it hangs like anything. So there are again multiple ways of doing 3D model in Fusion, tips and tricks. Anyways, but it is a very practical, very good software, I would say, and I would really recommend, because you can do surface modeling, because the hull part, this part is modeled by surface design. This thing can be very well done in Fusion, but in SolidWorks you cannot do. In CATIA you can do, but if you guys are honest and not using a pirated version, it will be really expensive. So yeah, again, Rhino is another software where we can do surfacing, but engineering, detailing, or design becomes very difficult. Okay, so we did the proper CAD modeling of it. And now the most important part comes, how to do this entire thing in 3D printing. So here I want someone of you to answer, give me a guess. I mean, how this thing we might have 3D printed. I will give you some tips. We did the 3D model, we gave the thickness, then we split this entire thing into multiple sections so that it will fit inside the 3D printer, and we do a 3D printing, done. Ooh la la. Okay, yeah. So yeah, someone please, Hemant or Hemant, you are trapped. I want you to again answer. Or who was the other guy? Siddharth or Shravan, right? Anyone?
You said it right. By
Who is it? Who
means
is it? Who is it? Shravan. Ah, yeah,
Shravan.
Shravan, you are back, man. Come on. Tell me how to 3D
By
print.
splitting into different sections and printing one by
Okay,
one,
then
and
I
then
have a doubt. I'm
yes.
having more doubts than you. How to 3D print this handrails?
Okay.
And again, how to if you 3D print, I hope you have seen a 3D print and you know how difficult it is to polish the 3D print, right? To do the
Yes.
post processing. Yeah, so if I 3D print it, then how I can post process these fragile parts? Think about it. Okay, you take a break now. So I will tell you, even if I say it is 3D printing, and again, this thing is 1 meter long. If I 3D print it in professional 3D printers, for example, the standard rates ranges from 10 rupees per gram to 25 to 30 rupees per gram. Okay, so and the entire thing is some 2.5 to 3 kilogram print. So how much it will be? If you are charging like 10 rupees, then it will be some 30,000 print, right? Or the print itself can shoot up to anything. So it is not possible. So what we did is like, these are the 3D printers available in NIT Calicut. These are not Cartesian based. These are Delta type printers, and these are very expensive machines. But yeah, so we tried printing in this, but we end up with a lot of cracks and everything. So most of the parts we were unable to use. So then again, here we have got a bed size of 70 centimeter by 30 centimeter. So almost half of the board will be fitting inside. But since there was some, as I told, some cracks and all those issues, we have to do most of the printing in our small machines, regular Ender 5 machines, which are costing around 30,000 rupees and all. And it takes a lot of time to print on these machines. So we changed the nozzle diameter to 0.8. 0.4 is what comes with the standard machine. We changed to 0.8 and we put everything in an enclosure. And since the part was really large, we have to stick with, a lot of tape. These are aluminum foil tape, generally known as duct tape, because these are temperature resistant because it is a metal tape, right? And the adhesive is also very good. And that is how we are actually doing the print. So what we have to do is like, we have to cut the whole part, basic components into shapes so that it will fit inside this. And what we did is like, we printed the 3D printed the hull section. Okay, so you can see how it is 3D printed. So did you notice there are a lot of triangle shapes here, right? Hemant, did you notice? Sorry, Shravan, did you notice that?
Yes.
Okay, so why these things are coming? This triangle kind of shape. Any idea? I hope all of you know about STL file. Okay, in STL file, the issue is that if you don't export the STL file in high resolution, this kind of thing can happen because these are like the individual mesh, okay, which makes this shape. So this is another issue. And you can see there are a lot of cracks what is there in the 3D print. And, this is what actually a practically 3D print looks like. So 3D printing is not that easy, especially in, the low quality machines. Even if it is high quality, it is again, not that great. Okay, so when you are exporting the 3D prints, make sure you are exporting it at high resolution. In Fusion, there are options where you can increase the resolution. Then there is another format known as 3MF. 3MF, I would recommend someone to write it down somewhere. The 3MF is another format in which you don't have to worry about the compactability. Where if you are exporting it in millimeter and the 3D printing slicer software takes it in centimeter, there is a conversion and accordingly the model can scale. This is much worse when it is in, you are designing it in centimeter and the software takes it in inches. It can become a total disaster, especially you have such an expensive print. So, but if you do it in 3MF format, how it helps is that it eliminates this sizing issue. It automatically gets scaled up. Okay. And especially if someone is working on Blender file, it is again a must to convert that into 3MF because there is no option. So you have to export that into an STL format, taking in mind those scaling issues and everything. And again, Blender is again for those who know what is a Blender software. It is a free software and excellent one which is used for surfacing. These days, a lot of people are actually getting trained in Blender. But there is a serious issue where you export any STL file and you open it in a 3D slicing software, it scales down to 10,000 times or 1,000 times. That is some very weird thing what happens. So whatever millimeters you are giving, you will get in probably, meters you are giving, you will getting it probably in millimeters or even less. So you have to take note of these practical issues while doing the 3D printing. And when we were doing this long 3D print, we have put some attachments because it is something like a vertical structure, right? So as the height increases, even the small vibrations, what happens to the bed spoils the print. So we had to engineer it, do the vibration analysis sort of thing. And we have got an expert mechanical team who does that. Yeah. So you can see this is one of his laptop and this is our mechanical engineer. So yeah. Anyways, such kind of things has to be incorporated in the design itself. Okay. And you can see the hull part is printed. Now how to attach the superstructure? The superstructure is attached by making some 3 grooves which were already in the CAD design and acrylic sheets were laser cut and kept in those places. Thus, we were able to bring down the 3D printing cost to really minimum. Okay, so this is a lot of putty work. Almost we spent some 15,000 for doing the putty and post-processing the hull alone. Okay, this is what can happen if you have a disastrous 3D print. And this kind of slots were made, these things were inserted onto it. So all these parts were 3D printed. I mean, made and planned using the softwares. Then again, the top part, these parts are 3D printed. Then again, there comes a question: how do you join the 3D prints? You cannot just put a glue, because if you put something like super glue or cyanoacrylic resin, I mean cyanoacrylic glue, it is very brittle thing. It can break from the junction. So what you do, you can heat something like we actually used some hairpin, the metal hairpin, and we were heating it into red hot and inserting that. So it gives a very sturdy thing, and like this, we have to do various parts by laser cutting. So this is how it was looking at, after 3D prints and the laser cutting parts attached. Then it happened like the hull part, it got deviated little because of the heat issue. As I told, there was a glue which was made in the base. It got deviated slightly out. So then we have to deform it by heat and applying some Velcro tape for a long period of time to get it in place. Right. And again, the front part, this white thing was actually made using SLA 3D printing, the resin-based 3D printing, and we were attaching it because this part needs to be very precise and the most important part, right? So that we were SLA 3D printing. And this ladder, SLA 3D printed, these small things, what you can see, these buoys and the anchors are of like 1 to 2 centimeter in size. These were SLA 3D printed because that gives very fine detail. If you compare the cost of SLA 3D printing to FDM, it will be like 4 to 5 times again, something similar to SLS. Okay. Then finally the propellers and the anchor bolts where you have to, place it. And this was the final result, kind of pre-final, because on the top you can see we did some minor adjustment. So you can see the imperfections, what was there in the 3D print or anything, it is not really seen, right? And the handrail part, we were actually taking a metal wire, bending it and soldering it and in that shape and keeping it there. So metal wire, again, what metal you will use? There is a wire which is used for MIG welding. I hope you all are aware about MIG welding and familiar with that. Because if you haven't learned MIG welding, or if you haven't practiced MIG welding or TIG welding in your academics, it is going to be a big disaster, because this is one of the arc welding का time है ना, वो गया अभी. मतलब arc welding is out. The MIG welding or TIG welding is something like you have to be trained and practiced. That is very important. Okay. And make use of the workshops in your institute before you graduate, because nowhere else you will never find it that handy. And yeah, these things are hand painted and finely kept. So we were actually using MIG welding wire, because this MIG welding wire has got a copper coating on top of it, and which makes it easy to do the soldering operation. Okay. And after that we were painting it, and there is this blue things were actually sticker work. So this was the full size of the board, and there is an acrylic base, and there was a cover and everything, and finally it was delivered. And these things are actually sticker work. So this is one, I think, a practical example how we can use design, art, the knowledge of engineering, 3D printing, rapid prototyping, additive manufacturing, or whatever you name it, to make a practical product. So here what I'm going to say, I am very sure you are going to have a lot of sessions like this. Someone on 3D printing, someone on entrepreneurship, someone on pricing, someone on thermodynamics, maybe, you name it, you all know that. But more importantly, what you should learn is that how to use this knowledge combinedly to make something productive. Ultimately, how to solve the practical problems with your knowledge, with the knowledge what you have. I hope you all are, if you want to take one, get one takeaway from this entire session, this is what. Make sure you are learning how to apply the knowledge you are accumulating over the past 4 years when you graduate. Then we can be good engineers, we can be good problem solvers, and we will be good executioners. So all the best to everyone. I have exceeded 6 minutes anyway. I hope the session was informative at least. Okay, yeah, great. So any doubts you can ask, or else we can wind up.
The total cost of making this model.
Making this model, that is something like a close guarded secret which startups won't tell you. I will tell you something. No, nothing like that. The market rate of 1 meter long scale models are 2.5 lakh. Okay. But we were actually doing it at 40% of costing. That will be coming around 1 lakh. And we had an expense of around 70,000 total to make this, because this doesn't involve the time what I have spent. It is just for manufacturing it, getting the painting done, doing the 3D prints, transportation cost. Because currently my startup is incubated at NIT Calicut. From here, if you want to do a laser cutting, we have to travel 25 kilometers to Calicut, because there are machines available in the institute. This is same with almost all institutes. Because what I'm telling is that there is lot of issues what we are going to face when we do manufacturing, because the entire startup ecosystem is not that great in India or in Kerala. Kerala, it is again another story. I hope like all can reflect the same thing. To do some practical hardware prototyping or this kind of manufacturing. And most of the cases, there are no one competent enough to operate these machines, or there will be some issues happening in the machines, and this will be practically useless. So that has actually increased our entire overhead charges to 10 to 15%. So we were expecting a margin of some 30,000 rupees, but we finally ended up in some margin of 15,000 rupees. Okay. So, but what we got is like we got a lot of knowledge by doing such projects. And right now I am using it as a training material. So I can train people prototyping by using this kind of model. So I am kind of trying to recover the expense. That is what we are doing right now. And my friend, it is not really easy to do hardware prototyping in Kerala. And what I would urge is like, I hope there are a lot of faculties available. I mean, I don't know, at least few faculties who will be attending the sessions, or, few students who are interested to do at least the mechanical folks who will be interested to do some hands-on hardware kind of things. So what I would recommend is like, before you graduate, you start some cult in the college or some sort of tinkering lab, or maybe by the help of management funds, or maybe I think the best will be to approach your seniors who have a job, to invest something, to contribute something to the college, to buy some 3D printers or laser cutting machines or similar equipments, and have some weekend activities, like maybe the final years or whoever has attended the sessions can try to train their juniors. Like that, we have to create a ecosystem which is more receptive for design, engineering, prototyping, manufacturing. And when we speak about manufacturing or prototyping, the investors or the startup shouldn't fly from Kerala to anywhere else. So, okay, I hope like you got an approximate idea how much we gain from this project, anyways. But these days, the new projects, we are very strict on the margin. So we are now quoting like 60 to 70% of whatever is the international rate. Yeah. Any other doubt?
Okay, means I watched a documentary in which a machine was 3D printing houses.
Yes.
Okay, so I mean it's a NASA's competition where they will send robots to Mars, where they will build 3D printed hub, and then humans will go there. And what's your thoughts on that?
Excellent thought. I mean, 3D printing house are not a new thing. It's actually there. Even there is a Malayali startup at IIT Bombay. Sorry, IIT Madras, IITM. Array, dude, these are the kind of projects actually the academic institute the engineer should do. See, I will tell you whatever syllabus, even when I was doing my engineering way back in 2012 in Calicut University, we are having some outdated syllabus that doesn't teach you anything hands-on or anything practical. Okay, so never trust on the syllabus you have. Trust more on what is the knowledge out there. See, these are actually an IIT Bombay startup who designed this beautiful house. Can you believe this is 3D printed? I think these are the co-founders. These are Malayalis only. Everyone is doing, a brilliant job out there. So what I would recommend is like, you explore more about this. Maybe you guys can plan a visit to IIT Madras and, see these startup, interact with them. All these things are going to be made possible because, see, Will someone believe? Maybe 40 years back, someone is telling like, you pick something from your pocket and you can hear someone sitting in America and speaking to you. Is that even, have someone even thought about it? Probably not, right? Maybe even before inventing the radio. So what I would recommend is like, we have to be visionaries and we have to be very good in what we are learning. Okay, if you are doing the engineering, even if you like it or not, make sure you learn engineering, and after that you do whatever you want. Okay, and be updated about the current technology, current trends in um, uh, uh, whatever domain you guys are in. So in mechanical, if you are doing working on 3D printing, then make sure you do a proper patent research, proper market research, and see what all technologies can come in the future. Right? It will be possible. But don't limit like 3D printing is just extruding something and making it. Okay. Basically, additive manufacturing. What is Shravan? I have a very interesting doubt. Can you tell me an example for additive manufacturing from nature?
Uh,
Nature. Just tell me an example.
mm, okay,
Okay. So, have you? I hope you might have seen a tree, right? A tree. If you look outside, you can find a tree. How this tree gets its shape?
sorry.
I mean,
What?
a plant here. At a maran ചെടിയൊക്കെ ഇല്ലേ? അതൊക്കെ എങ്ങനെ ഉണ്ടാവണേ? Okay.
Like ഞാൻ കേട്ടില്ല. I mean, your sound,
Okay. Sorry.
your voice.
I was asking you. I hope you can see my screen, right?
Yes.
Yeah. What do you see? It's a tree, right? എടാ
No, I
മരല്ലേ അത്?
can't see. ഇല്ല,
You can't see?
ഇനി പോയി.
എടാ മരല്ലേ മരം?
മരം.
മരം, ട്രീ.
ആ,
ഒരു അല്ലെങ്കിൽ ഒരു പ്ലാന്റ്. ഓക്കെ, ആ ഒരു മരം എങ്ങനെയാ ഉണ്ടാവണേ?
മരം ഫ്രം എങ്ങനെ പറയണം? ഏത് മരം?
ഒരു
സീഡിൽ നിന്നുണ്ടാകുന്ന മരം ഉണ്ട്.
ഏതെങ്കിലും ആയിക്കോട്ടെ. മേ ബി എ ബനിയൻ ട്രീ ഓർ മേ ബി എ മാംഗോ ട്രീ. How this tree is getting that shape? Is it the water what gives its shape? I hope
no.
you know about photosynthesis, right? What
Yes.
happens in a photosynthesis? The chlorophyll converts what? It absorbs carbon dioxide, right? During daytime, it absorbs carbon dioxide in the presence of sunlight. And there is a chemical process what happens, a biochemical process what happens. It accumulates carbon, right? So actually, if you ask me what is additive manufacturing, this is a good example, a mango tree. It gets carbon molecules. It's a molecular level additive manufacturing, right? It gets the carbon from the atmosphere. This carbon is what actually getting converted on in the shape of a tree, right? It absorbs minerals from the soil. Together it forms the shape, right? It happens over maybe years, but that is a good example for additive manufacturing. Even the human body, how does a small baby become someone like us? Molecule by molecule, we are getting biomass, or we are getting flesh and bone, and that is how we all are there, right? And in human body or in plants, there is a difference that it sometimes shreds the tissue and it rebuilds it. So that can be the differences, right? But at the end of the day, if you ask me what is additive manufacturing, I would say നൂൽപുട്ട് ഉണ്ടാക്കില്ലേ, ഇടിയപ്പം ഉണ്ടാക്കില്ലേ, that is additive manufacturing. You have the batter squeezed and formed in a specific random geometry. Julebi ഉണ്ടാക്കില്ലേ, I mean julebi എങ്ങനെ ഉണ്ടാക്കുക? You have the dough and you pour that in hot oil, right? So whatever is coming as the dough, I mean as the julebi, that liquid thing, that is actually something having water, and you are pouring that to hot oil which is hydrophobic. That is the reason why julebi sambam is not actually dissolving or getting mixed in the mixed in what? In the oil, right? That is how it is formed. That is a good example of additive manufacturing. ഒരു വീട് എങ്ങനെ ഉണ്ടാക്കണേ? You keep brick by brick. You can consider that brick as the smallest unit. So actually it is kind of an additive manufacturing. So what I would recommend when you think about additive manufacturing, think from very basic level. Okay, only the FDM 3D printers are not additive manufacturing machines, right? Actually, before subtractive manufacturing, I hope like the additive manufacturing happened. You had a huge mountain and there was a forest. Then the water start flowing and the mountains were eroded to make, get valleys, right? So that is a subtractive manufacturing. There was a mountain which was additively manufactured, and. So that is how I think we have to conceptualize and we have to conceive something like additive manufacturing or 3D printing. Okay, these are not just fancy terms what you have to memorize, but it has to be deep rooted in our flesh and bones, I think. Then we can innovate. Then we can start cross-pollinating other ideas. Okay, yeah.
Thank you.
I think it is, as you coming to back to your question, I think all these crazy concepts, what we think, if you are getting time, you all should work on these crazy ideas. At least give a positive, approach these problems with a very positive note. Because a winner is always an experienced loser. Because in 2004 Olympics, I believe Usain Bolt was not able to even appear for finals. He was coming for fourth or fifth in semifinals. But he won the last three Olympics, right? So that is what. Never be afraid to fail. Okay, yeah. Anything else? If not, tata, bye bye.
Yes, Dinoj. Yes. Thank you very much
Yeah.
for a very interesting session. Right? Hope all of you have enjoyed. Anybody would like to give a quick feedback? I think Trijo sir is having some net issues, connection issues. Anybody else? Anybody can give a feedback? Right, doesn't matter. Okay, fine.
Yeah.
Anyway, I was.
Preeti ma'am,
Yes.
Preeti, just one more thing I would like to add. See, there will be a lot of sections what will be conducted by by these
Yeah.
programs or by the institute or whatever. But
Yes.
see, I will tell you from my experience in engineering, if you don't practice, nothing is gonna work. You hear like 1,000 lectures about 3D printing. If you don't 3D print, if you don't travel and explore the 3D printers, or maybe you pay some visits to these 3D printing companies and everything, or else it will be really kind of a waste. That is what I feel like from my experience. So I think there has to be some sort of follow-up sessions which are more important. Probably won't be covering in the base of
shall we? This is a group of students and faculty from 5 different institutes. So, do you mind having a group of different groups of them to visit our facilities and maybe we can have an interaction with you sometimes?
I'm always here anyway. I'm not going to leave.
Yeah.
Go anywhere. That is
yeah. So
but
you
what
all.
yeah.
Right.
But
so
what
the
I would
audience
recommend is
audience got an open invitation to visit our facility. I mean, Dinoj is having a very good facility here. So you all got an open invitation to visit us and see what they are doing so that you can have a practical exposure to what he told till now. Okay.
That's fine. Anyway, came back to me only, but yeah. But more than that, what I would recommend is that that is there because Kerala is always there. Now. Try to go out, man. Come on. If
Yes,
as a
yes.
part of the industrial visit or something, if you haven't explored the other parts of the country, please do that.
Sure.
Okay, go to
That is
IIT
a
Madras.
good piece of advice. Yeah,
Yeah,
definitely.
I would recommend, at least someone will, some students will take it as a personal initiative and try to explore the world, right? I mean, okay, yeah. Anyways, yeah.
Sure. Yeah. Right.
Yeah.
So
Okay.
obviously it was a very interesting session, Dinoj. So thanks a lot. We know how busy you are there in the office, having a lot of work. So thanks a lot for sparing this much of time for us. It's almost going to be 2 hours. So thank you, Dinoj, and thank you all the participants, especially from the different institutes who have come in and spent this much of time starting from 1:30 with us. Hope this session was useful in some way. And Dr. Basil as well as Dinoj will be here. So anytime you can come back to us. All your institute IIC coordinators back in your college are having our contact numbers. You can anytime contact us and ask for any further information on all these topics. So once again, thanking you, and here we come to the end of the session. Thank you, Dinesh. Thank you.
Yeah, bye.